criteria. How do we actually go and determine when that problem is resolved? So when we've actually gone and satisfied that and there's no longer an issue there. Because what we might find is that if a query is running at 10 seconds, for example, if we can reduce that down to 2 seconds, that's great. Yes, there might be some more performance tuning that we can achieve out of that, but realistically we've actually hit our goals, we've hit the SLAs that we really need to, and then that's our exit criteria. We can then come back and flag that to then focus and look at that later on down the track. We need to determine how we go about gathering the data. So what sort of tools do we go about using? And one of the things we're going to prescribe today is really this cookie cutter approach of how we can time and time again consistently get to the bottom of what all of our issues are in a very, very timely manner. Because effectively what we want to start to become is that triage nurse when we first go into the hospital. Because when somebody goes into the hospital, the first point of call and the first contact point you have is that triage register. That person that's a nurse at the triage register's responsibility is to then determine what that problem is with that person. Okay, is that person got a broken leg? Okay, we need to send them off to X-ray. Has that person got maybe heart attack? So maybe we need to actually bring in the cardiac arrest team to then start to work on them straight away. So they really can determine how we are doing it. So what are the tools that we use to quickly gather that data that allows us to then go and perform that triage? And then the last thing really is about analysing it. So what are the techniques that we go through for analysing it? And these are the things that we're going to cover in today's session as we go and look through the different performance tuning methodologies that we can go and utilise. So if we think about the issue itself, so understanding the issue, what the heck is the problem? So why is it there's an issue? It was running great yesterday, all of a sudden there's an issue today. So being able to isolate that issue. So one of the things that we need as DBAs to often do is we often don't get escalated until we're seen as that third level support. So there's a number of hands that the problem's been through before we even get to see it. And one of those things is what steps have been performed to date. So in other words, has somebody gone and made that problem worse before we're even aware of that? So really just looking through the records to see what changes have been made. The other thing we want to identify is, has anybody gone and done any of the hard work for us already? Have they already fired up Perfmon and captured that information? Or maybe they're using some other analytical tools to capture this information. But the most important question from a DBA's perspective is, how do I go about reproducing the problem? In other words, what's the repo scenario? Because if I can't reproduce the problem, it makes it very hard for me to isolate the issue, bring it into a test or a development environment and really nail what that problem is. Because there's some problems that we're never going to be able to reproduce inside of a production environment. So for example, a bank transfer. Gee, it'd be great if that went my way, somebody performance tuning and continually adding funds into my bank account. But realistically, that's not something that we can go and do in a production environment, is test that transfer of funds from one account to another. Hence the reason we need to be very clear about how we go about reproducing that issue so that I can then go and take that issue and then do it in another environment. So if we think about the different symptoms that we have of performance issues, so really there's really three main categories of issues that we come across time and time again. And this is something that I enjoy being a consultant, is the opportunity to go out there and talk to different customers. Because very often what one customer is experiencing is also what another customer is experiencing as well. And these three symptoms we have here are really the main symptoms that we come across time and time again in the field. Resource bottlenecks, so for example I/O or memory latency being an issue there, so identifying that. We then have temp DB pressure as well, because if you think about the way that SQL Server is structured, we've only got one temp DB database in there. Yes, we can then get some performance improvements around that by creating a number of different data files to align that with a number of sockets, but often that's actually a bottleneck there, and that's potentially because of the way that developers have gone and structured their query, but it's also because that SQL Server in the later versions is utilising temp DB a lot more heavily than what it was in the past. So for example, things like database snapshots and change records are all utilising temp DB. But the other thing that we really often have problems with, and really it's a manifestation of these other two, is our slow running queries. Because I don't know about you guys out there, but my SQL Server boxes run great without any applications sitting on top of them. As soon as I bring an application into play, that's when I start to get these performance bottlenecks. And we all know that those pesky developers write fantastic SQL code, don't we? What we want to be able to do then is identify what's causing that problem. That's really that Pareto principle of the 80-20 rule. What are the top 10 worst performing queries on my box that I can then drill into and focus my attention on? And really, how do I easily reduce the signal to noise ratio? Because if you think about a box that's being hit very, very hard, there's a lot of transactions that are coming through all the time. How do we easily go and identify what's the performance bottleneck that we've got there? And that's what we're going to show in today's presentation, is those tips and tricks that we can go and use as DBAs to really isolate these symptoms and identify what really is causing this poor performance. We might be seeing some issues with memory, but are those issues with memory simply a manifestation of something else on that box? If I was to then go and fix that problem, is that then going to then make all of my problems go away? So that's what we're looking at. So when we come about troubleshooting, what we really want to get into is we want to get into what I would call a data-driven troubleshooting. And that's where I know what tools that I'm going to go and use to go and collect my data, and then how do I go about reading and analysing the data. Because there's nothing worse than actually collecting all of this information and then not being able to go and do anything meaningful with it. So what I want to show you is the tips that we can use in order to then go and analyse this data. So what tools do we use? What data that I look at? So if anybody's fired up Perfmon, you'd see that there's thousands of counters in there. So what are the appropriate metrics that I want to then go and capture that are then going to, in order, allow me to very, very quickly isolate where my performance bottleneck is? But what we're going to be focusing really in today's session is how do we go about reading and how do we go about analysing all of this data that we capture. So when you think about all of the tools that we have inside of our arsenal today, you'll see that we've got a wide varied list listed up on the screen. We've got everything from looking at our SQL Server error log to maybe going and using a tool like SQL Nexus. We've got all of our DBCC commands and our DMVs. But really what we're looking for is we're simply looking for that SQL Server Go Faster switch. Now, I don't know about you folks, but I've worked with SQL Server for quite a period of time, and I've tried DBCC do this, SP configure do that, put a trace flag on, and I haven't been able to get SQL to go faster. The only way that I've been able to get SQL to go faster is to actually go and use the appropriate tool to drill down and identify where my performance bottleneck is occurring, analyse that data, and then go and make an informed decision about that. There's no point in tweaking this and doing that. Maybe I go and change my max stop setting, or maybe I do an SP configure on my memory and things like that. We want to actually make all of those decisions based upon the evidence that we're actually seeing, rather than just randomly going and finding an article on Bing and then going and trying that article that we found with our search. So when we're talking about SQL Server performance, we've got three main areas, and one of the areas that we've got is actually our server performance. And as we said before, one of the things that we want to be able to do is we want to go and be able to play that triage nurse. We want to triage where the problem is. Because if you think about a box inside of our organisations, often SQL Server is not the only thing that's running on there. So very quickly we want to then be able to say, look, is it really SQL Server that's causing the problem? Because as DBAs, you all know that the first thing that gets blamed for the performance problem is it's always the database's fault. So what we want to be able to do is easily then go and isolate, is it the database that's causing that problem? And the way that we go about doing that is we go about using our good friend Perfmon, or Performance and Reliability Monitor. Because what Perfmon allows us to do is it allows us to drill in and identify what the problem conditions are, and then what it also allows us to do is isolate what those conditions are and look at the scope of it, because we can then go and see which particular metrics are then causing me my issue. And it also allows me to drill down and see, look, is it really SQL Server that's causing the problem, or is there something else on that box that's causing the issue? Because what Perfmon allows us to do is it really allows us to have a server view at that particular server level to very quickly isolate the issue. But one of the problems that we have when we capture all of this data with Perfmon is just simply the sheer amount of data that we have to analyse. And one of the tools that we can go and use in order to automate this analysis and really, I suppose, leverage some of the existing tools out there, it's an open source Codeplex product known as PAL, so the Performance Analysis for Logs. And that allows us to go and take a Perfmon file and then identify very quickly and easily where the bottlenecks are in that file. So what we're going to do is we're just going to take a quick look at our good friend Perfmon, and then we're also going to look at how we go about using PAL in order to go and perform this analysis. So what I'm going to do is I'm going to open up Perfmon here. At least that's what I thought I was going to open up. And once I've opened up PerfMon, I've got a number of different things that I can do. So I can click on Performance Monitor, and that's just going to give me a real-time snapshot of what's happening in my environment. But the problem is by default when I open it up, all I get is I get CPU. CPU, although it's important, it's not the be-all and end-all of everything. So one of the things that we've got inside of PerfMon is we've got a number of different data collectors. So if we have a look at these different data collectors down here, what you'll see is that out of the box, we've got our system diagnostics and our system performance. So these collectors are pre-built collectors that are available out of the box. So what I'm going to do is I'm just going to quickly start one of these, and what it's going to do is it's going to run for 60 seconds, and it's going to take a real-time snapshot of everything that's going on in my environment at that particular time. I can also go and configure these as well, and when I configure them, it allows me to then go and add additional things like capturing system configuration information. So I can then get a report that not only gives me performance at the end, I can also go and get a report that gives me things like the amount of memory on the box, the type of CPU, how many CPUs I've got allocated there. Because what you'll see down in my reports, in my system report, is you'll see that it's collecting that data at the moment. We just need to wait for 60 seconds and then we're going to have all of that information available to us. But we can also go and create our own user-defined data collectors. So in order to create our own user-defined data collector, we can click on New and New Data Collector Set. We then simply give that a name and we can manually go and create that, because what this allows us to do is actually have a pre-built template that allows us to run it when we think we've got a performance problem. So we can pick and choose what metrics. So for example, do we need to go and focus on the SQL Server lazy writer? Are we looking at buffer cache hit ratio? What are the specific metrics that I need to capture? So you'll see here that I go and tick, I want my system configuration information. Actually, let's just go PerfMon information. Next, we can then go and add all of our counters in here, and this allows us really to have that one time. And allows us to also we can create this data collector and move it from one server to another. Because one of the things that you'll see here is that I've already gone and created a data collector. Now this data collector here I've called SQL Server Performance. I can go to the properties of that, and you'll see inside of here I've already got a number of different collectors added. Where are we? Sorry, on my data collector, not the collection itself. Right-click Properties, and you'll see that there are all the PerfMon counters there that I've already got configured. So I'm just going to come back now to my system diagnostics into this report that I've run. So what you'll see here is in one convenient location, what it's gone and done is it's gone and looked at my event log, and I've captured any issues that I might have been bubbled up into my event log there. You can see I've got any resource utilization, so you'll see that everything's great at the moment. It's that traffic light scenario of green is everything's good, orange some corrective action, red we've got a real problem. You'll see straight away that I can identify that I don't have a problem with any of these standard measures because they're green. I then get a snapshot of what the utilization of each of those is. I can then go down and see what software is being configured, so I can go and see if I've got the latest service pack, what's on here, various different filtering options, and CPU. So this is something that I can use as a tool to very, very quickly go and just get a snapshot of how does that box look at this particular point in time. But what it also gives me the opportunity to do is baseline that box as well, because I can look at what is the performance of it now versus what the performance was last time I ran this. And that's one of the most important things that we need to do as DBAs, is really look at how do we go about getting our baseline. Because if somebody calls up and says it's running slow on a Tuesday morning, how do we know if that's normal or abnormal behaviour? What we might find is that on Tuesday morning that there's a batch process that runs. If we had a baseline, we'd be able to then be able to say, look, straight away, look, there's nothing out of the ordinary, this is running as per normal. Otherwise, what we would need to do is go and focus a lot of attention and time on a problem that we might identify that's really not a problem at all. So the way that we can go about analysing all of this a little bit further is by going and using our good friend PAL. Now, PAL is an open source tool that we can go and download from Codeplex. And what it allows us to do is it allows us to walk through a wizard. This wizard allows us to then go and grab an existing perf file. What we can do is we can actually look at what time range in that specific perf file we want to look at. And what you'll see is it just drives us through this wizard here. So we can then go and choose whether we want to actually, what type of overview do we want to do, so what type of machine is this, because different types of servers have different characteristics to them. The way that an IIS server behaves is very different to the way that SQL Server behaves. So we then go and select that particular threshold. Once we've selected that threshold, we then need to enter a number of pieces of information, such as the number of processors. On my little laptop here, it's just one. Okay, so we need to, is 3GB enabled? No, it's not enabled. We also then need to say, is it 64-bit? Yes, it's 64-bit, and the total amount of memory is 8 gig. So we can then go and click Next. We're just going to click through Next here, and what's going to happen here is it's going to take around about 60 seconds or so. And what it's going to do is it's going to take all of that information that we've gone and captured inside of that perfmon file, and it's going to do some great analysis on it. And what's going to come out of the other side is we're going to get a great HTML file. It's going to produce some lovely little graphs for us. So if we want, we can copy and paste those graphs, paste it into an executive report, and basically get a pay rise because it's just going to look so good. But really, what it allows us to very quickly do is isolate where that issue is. Is it CPU? Well, CPU might look pretty ugly, but what Power will allow us to then do, is it really CPU, or is it something further downstream that's actually really going and causing that performance bottleneck? And that's one of the challenges that we have working with perfmon, is how do we go about easily isolating and identifying all of this information. So we can simply just go and download this tool from Codeplex and run it, and very, very powerful for performing all of this analysis. So the process that we go through there is we go and create our own custom data collector. That custom data collector allows us to then go and capture the information that we need. Once we've gone and captured that, we can then have a look at the reports that are generated by the data collector. From the data collector, we would then go and run PAL, and then PAL was going to go and generate a great looking report for us that's really, I suppose, going to save us a lot of that time that we would have had to utilise in the past, because often it's very much a manual process of trying to isolate where the needle is in that haystack that's causing that server performance there. So you'll see that at the moment it's actually just generating the HTML report. It just takes a couple of seconds. Once that report is generated, it'll then open up for us and we'll be able to have a look at that. So what you'll see here is I've got a sample perfmon file. You'll see it's going and creates a nice table of contents. I can then go and see any of the performance conditions where I've got issues. That same thing where red, we've got a problem, orange, a bit of corrective actions required. As you'll scroll through here, you'll see that we have, for example, a graph on logical free space. So that's logical free space over the time that this tool was utilised. You'll see that then we've got a number of different charts and graphs, and very easy for us to then go and use this information. So that's what Power gives us, is the ability to go and take a file that we've generated with performance and reliability monitor, also known as perfmon, and then go and consume that, and then easily go and isolate where the issue is. So the next thing that we want to look at, so we're walking through the methodology. First of all, we've gone and identified, is it the server that's causing us the issue? We've looked at the server, we've said, okay, yeah, it does look like there's a bit of a problem with SQL Server. So we now need to lift up the hood on SQL and identify, look, what's causing that? And the easiest way for us to go doing that is going and firing up a trace. Now look, we've got a number of different ways that we can go and use SQL Trace, because really SQL Trace is just the technology that allows us to see what's happening to SQL Server at a particular point in time. Now we've got Profiler, which is the UI or the user interface, which is done client side, or we've also got what we call a server side trace. Now the big difference between the two is the performance impact that it has on SQL Server while we're running it. So we've got very, very marginal performance impact when we go and use the scripted version, which is our server-side trace, versus our client-side. But we don't get the nice UI. But what we want to be able to do is we want to automatically go and run this server-side trace. We can then capture that output, and then once we've captured the output, we want to then go and utilize that, and we want to utilize it inside of the UI on this client side. So rather than actually running the client connecting to the server, we want to run the trace on the server. Now this is not the UI, this is just the trace script, and then capture that and then do the analysis directly on that. So one of the things we often have with SQL is we often have a concept of blocking. Now, blocking is not a bad thing. Blocking is a bad thing when it's a long-running block, because blocking is simply SQL Server adhering to the ACID principle. Now, if I didn't have a block, what that would mean is if somebody was trying to update the same record at the same time that somebody else was updating it, we would then have issues with who's in, first out, first in, first out, and issues around data consistency. So a block is not a bad thing, because a block normally manifests itself as a logical lock that's gone and being applied on a particular row or a particular page, or maybe an extent or even a table. The problem with blocking is when we've got very, very long blocks. Like, for example, if somebody's gone and taken out or opened a transaction, hasn't closed it off, that transaction's still running, so I can't go and make any changes to the underlying data. So does anyone want to share with me maybe what they would use or what tool or process in order to then go and identify blocking? Activity monitor, yep. Yep. SP Who To? Yep. Input buffer to actually have a look at what's currently in that buffer for that SPID. The problem with all of these tools that we've mentioned is that allows us to see what's happening in real time now. So what's blocking at this particular point in time? The challenge is often what happens is we go and get a call that's come in from the service desk. By the time it's come through to us, it's 20 minutes later, we don't have the ability to easily then be able to identify with these tools what's happened in the past. So one of the things that we've got from a server configuration is the ability to go and use spconfigure and go and set the block process threshold. Now what block process threshold allows us to do is just say to SQL Server, what is the threshold in seconds for a block to be running before that's bubbled up as an error? Once it's bubbled up in an error, I can then easily go and capture that, because what it does is it shows us what the head of the blocking chain is and then all of the other processes that's being blocked and why it's being blocked. So it allows us to say, look, if that's running for longer than 10 seconds, bubble that up, because I then want to be able to then see what that issue is. And that's also an event that I can then bubble up to go and use and identify and profile it as well. So as soon as that event occurs, I then go and see that inside of Profiler. So let's have a look at how we would go about using that. So what you'll see here is I'm going to go and configure. So it's an advanced option. So the first thing that I need to do is actually configure my advanced options to true and then do a reconfigure. Once I've done that reconfigure, what I then need to do is I then need to go and set the block process threshold. In this case, just to demonstrate it, I'm actually setting the block threshold to 2 seconds. That means if I get a block for more than 2 seconds, what's going to happen is I'm then going to bubble that up and I'm going to be able to easily identify that we've got some blocking activity occurring there. So let's go and execute that. Okay. So I've executed that, so I now want to be able to create a SQL trace that includes that information. So what I'm going to do is I'm going to open up my good friend Profiler. Once I've opened Profiler, what I'm going to do is I'm going to create a new trace. So I'm just going to connect to my default instance here. I'm going to call this, I'm going to call it TechEd New Zealand. TechEd NZ. So you'll see that I can go and use an existing template. So I've got a number of different template options here. But the other thing that I can do is I can also go and create my own template. So rather than simply accepting what comes out of the box, I can then go and create my own. So let's go and I'm just going to select the standard and then I'm going to create a template based on that. Now one of the things that we want to do is we typically want to go and save this trace directly to a file. Now the reason we want to go and save this trace to a file is because obviously if I've got performance issues on my database, the last thing that I want to do is put additional load on that SQL Server instance by trying to write that into a table there. So typically I would go and save that directly to a file. You'll notice that I've got a maximum file size, and that file size is the size that the file will get before I allow it to roll over. And I've got the option to allow it to roll over or not. In this case, I'm going to enable it to roll over. And then I'm going to come across to my event selection. Now this allows me to then go and choose which events that I'm interested in. So in this case, I'm really not interested in the audit, so I'm not worried about when somebody connects. And I'm not worried about any of my sessions. All I'm really interested in this particular scenario is when my TSQL command actually completes. If I select starting and completed, I'll then get 2 entries for every command. I'll get an entry for when that command starts, and then I'll get another entry for when it completes. But I'll get all that information anyway out of my completed because I get the start and finish as well as the duration in there. So just to remove some of the noise that we've got there. But the other thing that we can do is we can click here, show all events. So when I click Show All Events, you'll then go and see all of the different events that I can select from. So you would have seen we had an audit event, we also had a stored proc event, and a TSQL event. But in this case here, what I want to do is I want to go to Errors and Warnings. Inside Errors and Warnings, what you'll see is that I've got my blocked process report. So what that means is that when I have a blocked process, that then throws that information up into SQL Profiler. So SQL Profiler will capture that. Now, very similar to the way that when we've got a deadlock and we've got the ability to capture a deadlock graph, when we've got the deadlock graph, we can see all of the connections that are involved in that deadlock. We can do exactly the same thing with our blocking. We get to see who the head of the blocking chain is and then all of the processes that are being affected. But more importantly, what's the resource and what's the reason why that block is occurring. So what I can now do is I can run this, and this is actually running interactively. And effectively, this is actually like lifting up the hood to see what's going on. And the analogy that I have around this is if we were to go and take your car into a mechanic. Now, a mechanic's not going to walk around the car and kick the tyres to try and work out what's wrong with the car. He's going to put it on a diagnostics machine. That diagnostics machine is then going to be able to tell you, is it a problem with the spark plugs? Is it a problem with the carburetor? What is wrong with this car? So effectively what SQL Server Profiler allows us to do is lift up the hood and allows us to go and see all of the connections that are occurring to SQL Server. So look, what I'm going to do now is because I'm going to create a trace file that I want to be able to use later on down the track. In other words, what I want to be able to do with this trace file is I want to go and create a new template. So I'm just going to stop this trace here. What I'm going to do here is you'll see I can go File. And I can go Templates, New Template. Okay. So what am I going to call it? So I'm just going to call this one TechEd NZ. So you'll see the event selection, so I can then go and choose all of my event selection. But what I can also do is I can actually just simply save my existing one here. So I can actually save that as a trace template. So I can create the template from scratch, or alternatively I can inherit and use my existing template. So let's use that one. So it's successfully saved that. The other thing that we can do with all this information is we go and save it as a trace file or a TRC file. So you'll see here under my Save As, I can go and save that as a trace file, and that allows me to then just go and grab that. So I'm just going to call that trace and save. Okay. So we've taken that information, it's a snapshot at that point in time. We can then go and analyse that at a later stage. So what we've walked through in that demo there is quickly how do we go about using the blocked process threshold, how do we go and use that inside of a profile when we actually go and run a trace, and then finally how do we go about creating a template that we can use later on down the track. Okay. So the next thing we're going to talk about is we're going to talk about weight stats. Now, the whole theory of weight stats really is that the total time for a query to run is made up of two things. The first thing that's actually made up of the service time, so actually doing something, and then the other one is actually made up of the wait time. And really, it's like standing the 8 items or less queue, because if you think about what's inside of SQL Server, what's the engine of SQL Server? Does anyone want to share with me what they think the engine of SQL Server is? What's the engine of any computer? Processor, CPU. So if my processor's not doing anything, that effectively means that my computer's not doing anything. If my computer's not doing anything, then SQL Server is not doing anything. So what wait stats allows us to capture is an accumulation of all of the time that that operation was performing, plus the time that it had to wait. So in other words, if we think about the 8 items or less queue in the supermarket, I'm standing in the 8 items or less queue and I've got 3 people standing in front of me. So my total wait stats is the time it took me to go from the start of the queue actually up to the checkout, plus the service time, so that's the time that all of my items were being scanned before I could then go and leave the supermarket. Because what SQL Server does internally is every time it needs to wait for an event, it doesn't matter whether it's waiting for I/O, whether it's waiting on a lock or a block, or whether it's waiting on something else, all of this information is recorded inside of wait stats. So what that means is I can then easily go and identify what's causing that problem simply by going and looking at wait stats. So weight stats is really just that ability for us to look at what is the accumulated period of time that an operation has been running, and then easily go and lift the hood and find out what's going on. So let's have a look at how we go about utilising weight stats. Okay. So what I'm going to do here is I'm going to look at the Dynamic Management View DMOS weight stats. And what weight stats does, it's an accumulation of all of the weights that SQL Server has required since the last time the service was stopped and restarted. So if I execute that command, what you'll see is that, because I've ordered these based upon wait time, so you'll see that these ones at the top here we've had to wait a fairly long time for. And we can then break that down and find out what is it that's actually causing all of the waits. So for example, we've got CX packets there, we've got some DAC down here as well. All of these different operations and wait types then relate to a particular performance condition. So what was causing that performance condition is what weight stats allows us to do. But when we look at this, it's a snapshot of since when the SQL Server service last started. Now that might have been a month ago, and we might have had some real performance issues a month ago, and I'm not interested in those. So I need to be able to go and isolate those. Now the way that I go about isolating those is by collecting a delta of the weight stats. So in other words, what I'm doing is I'm going and taking that information, I'm going to select it into a temporary table, I'm going to wait a couple of seconds, and then select it into a temporary table. What that means is I then get a snapshot in that 2-second period of everything that SQL servers then had to wait on. Now we might need to extend this for a longer period of time to capture the specific event that we're looking for, but just to show you what happens here. So we're going to perform our collection. So now that we've performed our collection, what we can then do is we can actually perform a join on both of those tables, and we can then go and identify all of the weights that happen in that particular point in time. We can then go and look up what that specific weight event is and identify then where that issue was. Now this is effectively, once again, allowing us to go and play that triage nurse. So in a disaster, in a natural disaster, what will happen inside of a hospital is that triage person will get a number of coloured cards. So as somebody comes in, so let's say for example there's a large fire. All of a sudden what they'll do is they will mobilise the triage department and they'll provide them with the cards. Those coloured cards they'll then put on each particular person that then comes into the hospital. Green might mean this. Black might mean this person's got no chance, leave them alone. Red might mean something else. So all of these cards have got a particular value associated with them, and it's meaningful for somebody else to be able to interpret. What weight stats are is effectively those coloured cards inside of that triage unit. It allows us to identify what exactly is causing this problem, because then we can go and focus all of our attention on that specific issue. Now it's like somebody coming in with an injury. What you might see is that all of a sudden they've got a lot of blood coming out of their leg, but you can't see anything else wrong with them. What it might be, though, is that they don't know that there's something else wrong with them. Maybe they're hemorrhaging from somewhere else in their body, but it's not visible. What we want to be able to do is not focus our attention on the wrong spot. We want to focus our attention on what is that life-threatening critical event, or in other words, what is the real root cause of SQL having an issue. And that's what weight stats allows us to do, is get very, very close very quickly to what the performance issue is. So what I'm now going to do is just go and show you another dynamic management view, which is OS wait tasks. And OS wait tasks is a snapshot of the current wait events happening right at this particular point in time. But what I want to do is I want to demonstrate quickly how weight stats allows us to isolate where the problem is. So we might have some poor performance on our server. We're not sure where it is. We've gone through the process there. We've gone and run perfmon. Perfmon said, yeah, SQL's got a bit of a problem there, so we need to look a bit closer. We've gone and run profiler. Hasn't been very evident about what the issue is. So we want to then go to our good friend weight stats and see, does weight stats allow us to see where the issue is? So what I'm going to do is I'm just going to perform a simple update here. So I'm just going to do a begin tran, update northwind, .dbo, employees. So I set employee, just going to set last name equals Ward. So I'm going to set all the last names to Ward. Okay, so I've got a begin tran. I'm going to open up another connection here. So what's going to happen here is when I execute this statement, when I can finally learn how to type, is I'm going to get a block. Now that block's expected. That block is good. That block is stopping me from getting a dirty read. That data is actually inside of a transaction. It has not been hardened. It has not been committed. So hence, I want that block to actually adhere. I don't want to be able to go and see that dirty data. But from a user's point of view, we've got poor performance. We've been sitting here for almost 20 seconds now, not getting a response from my query. So look, call up the DBA. So the DBA is going to go and use our newfound knowledge with wait stats. So what you're going to see here is I'm going to go and join current exec sessions with wait stats in order to then go and identify exactly what's happening. So what I can do is execute this now, and hey presto, I've then been able to isolate where the issue is. I can see the issue is with this particular session here. The reason is because it's been blocked by that particular session there. I can see what the resource lock was, what the name of the application was, what the name of the text that's being blocked is. And then also I can then go and see how much CPU and how much memory usage. And this is really interesting, because if I look at my CPU time up there, you'll see that CPU time is 0. Now remember, we said that only when SQL Server is actually doing something if the CPU is not doing anything, SQL Server is not doing anything, which means our application is not doing anything. In other words, that query, that select query, is not doing anything because we haven't got any CPU time. So what we want to be able to do from a SQL Server perspective is maximize the amount of CPU time. If we're maximizing the amount of CPU time, it means that we're actually doing something. So if we were to go and have a look at this in SQL Server Profiler, we might go and suspect that that select statement is a poor performing query. And the reason that we would think that that select statement is a poor performing query is because the duration now is probably up to about 1.5 minutes. However, it's not poor performing because it actually hasn't done anything. By using wait stats, it allows us to isolate and get to the bottom of the root cause of the problem and not focus on something that may not necessarily have been the issue. Because I don't know about you, but if I was looking at duration, that one would stand out really clearly to me that there's an issue there. But it's not an issue at all, because we need to also take into account not only duration but also total CPU time as well. So let's just go and roll that transaction back now. So that statement will now completed successfully. So if we were to go and run that again, we're not going to see anything because we don't have any current issues there. Okay. So what I want to now do for the rest of the session is I want to go and bring it all together. So what we've really spoken about today so far is we've really gone and spoken about how do we go about using perfmon, how do we go about using PAL to go and interpret all of that information that's come out of perfmon. We then looked at SQL Profile and how we go about using that. We also looked at some of the things that we can go and use with our block threshold as well to make it easy to identify blocking and when we have long-running blocks. And then finally we had a look at wait stats. So that's what we're going to do now, is actually bring all of that together, and we're going to actually create a real-life scenario. So what I'm going to do is I'm going to utilise that existing trace that I've created earlier, and I'm also then going to use that custom data collector that I created also while I was directly inside of perfmon. So let's get started. So the first thing I'm going to do is I'm just going to come back to perfmon here. What I'm going to do is I'm just going to bring up my performance data collector here, just so I can see some issues when they occur. Next thing I'm going to do is I'm going to come across to profile. I'm going to create a new trace. Now what I'm going to do is I'm just going to do it using the UI, and the reason I'm doing it using the UI is so that you can actually see the interactivity. Otherwise I'd normally simply do this as a server-side trace, and we wouldn't get to see what's happening under the covers. So one of the things you'll see is I can go and use my new template here. So I've got my TechEd user template. That was the template that I created earlier. I'm just going to run this interactively because I'm then just going to save that to a file. So what you're going to see now is just any activity that's occurring on this SQL instance. Now you'll see that there's a bit of activity happening from reporting services. I left reporting services running on this machine just so that we could actually get a little bit more noise to really simulate what happens inside of the real world. But what I'm going to do now is I've actually got a poor performance test harness. Now if I have a look at this, it's just simply a batch file. What this batch file is going to do is it's going to go and call a number of different procedures. The first thing it's going to do is it's going to shell out and call a VB script. This VB script is going to go and dump 10,000 connections straight in my transaction log. That way it's going to create a lot of noise, make it very hard for me to identify what the real problem is. I'm then going to issue a long-running transaction. Now that long-running transaction is then going to force some blocking that's then going to occur elsewhere in my application. I'm then going to put it into a CPU-intensive loop, because what I want to do is I want to go and put CPU off the chart. So what we're really trying to do here is actually create that real-world scenario where we've got lots of noise. CPU spiking 100%. We've got lots and lots of different commands that are happening inside of our box. How do we identify them? And then finally, I'm going to run a command that's got a missing index on it. So that's what we're going to do there, because what we want to do is there's really only 2 poor-performing queries, and we want to be able to isolate those. So let's go and run my command file now. So it just takes around about 10 seconds for all of this to get excited. Okay. I'm just going to stop that, because what you'll see here is you'll see that obviously I had a massive big CPU spike. I've come in, I've fired up perfmon, I've gone, whoa, there's a real problem here. I need to go and get a little bit down and dirty with it and find out what's going on. So you'll obviously see that that other connection has now dropped out. So let's go and close that. So what you'll see is if I come across now into my good friend Profiler, that there's a lot of activity going on here. So very, very hard for us to isolate what's going on. So what I want to walk through you now is that methodology of how we go about taking and identifying where this performance problem is. So we're going to walk through that end to end. So the first thing I'm going to do is I'm just going to save this as a trace file. I'm just going to call that trace, for the want of a better name. Yeah, that'll do. Cool. So what I'm now going to do is I'm going to come back inside of Management Studio. Now the reason I'm coming back into Management Studio is I wanted to go and show you how we can go about bringing that information in. Because one of the things obviously as DBA is one of our real strengths is our ability to write SQL statements. So what I want to do here is I want to go and use the function fn trace get table. What that's going to allow me to do is it's going to allow me to go and take that SQL trace file and it's going to bring that directly into SQL Server for me. So I can then go and write things like sort by duration, sort by CPU utilization. So I'm just going to execute that now to bring that in. It doesn't exist. Let's go and have a look at what double C. Thank you very much, folks. Now I've got that object, so let's just quickly drop that temporary table. Beautiful. Take 2. Happy days. So what that's going to do is it's gone and loaded up all of that information. So about 30,000 records that I had inside of my trace file directly into a table inside of SQL. So what that means is I can now go and analyse that. Because what you'll see is I can do things like this. I can go and grab my top 10 by duration. So these are the top 10 queries that had the longest duration. So if I scroll across here, you'll see that there's my duration listed down there. I can then go and also do things such as top statement by CPU utilization. Because remembering, we don't want to ever look at duration in isolation to CPU. So that's all well and good, but what I want to do is I want to actually then go and use some of the dynamic management views, because what the dynamic management views allow me to do is really have a look under the covers and find out, look, what were the queries with the average CPU time? So that's what I want to try and determine here is, what are the top 10 queries with average CPU time? Because they're, I think, going to be my suspects of where I think my performance issue is going to be. So what you'll see here is I've got a number of different statements here. So what you'll see is I've got a select into, I've got an insert, I've got a couple of statements here where I think that we might have some performance issues. Now some of the ones that look interesting to me here at the moment is, this one here. Select name, modify date from store, where name equals 1 and modified equals 2. Why is that performing so poorly? So straight away I'm going into that sort of investigative mode. I'm asking myself the question about these queries. Now if I look at the top one, I can easily isolate that and identify what the performance problem is. Can anyone tell me what the performance problem in that first query is? Well, it's got a cross join in it, so of course it's going to have poor performance in there. So I then need to go back to my dev team and go, folks, why are we using a cross join in here? Do we actually need that? Or are you actually doing a cross join and then doing a distinct over the top of that in order to just stop getting duplicate records? So what we'll see here is all of the queries that's causing all of our problem. So the problem though is if we just focus our attention back on this particular select statement, actually let's go and get top 20 because I just want to get one more query actually that's actually I know that's going to be an issue in here. So the other one that I think is going to be another issue that's a candidate is this update statement down here. It's very, very simple. Update person, set last name equals foo, where business entity ID equals foo as well. But one of the things that you'll notice is that when we went and pulled this information out of the dynamic management views is, what are we missing? What we're missing is we're missing the parameterized value, so what the value really was. So we can go and see that last name equals 1. Well, we might actually have some poor performance in that, for example, if we're doing it on Smith, because obviously there's going to be a large number of Smiths directly inside of that. So it might be a candidate there that we need to then maybe go and create a filtered index. But let's dive in a little bit deeper to that. So what I'm going to do here is I'm actually going to pull up my trace file. Because what we're going to do is I'm actually going to pull up my trace file and look for where the word store is utilised. And what you'll see is I can actually now see the exact statement that was issued. So I'm able to isolate what the issue was, come back to my trace file, and then find that statement. So you'll see that where the name equals sharp bikes and modified date is greater or equal to that particular date there. So let's keep walking through this process about how we go about identifying where the problem is. Now, one of the things that SQL Server utilises to actually determine what the process is and how it gets to that particular, how it executes that query is the execution plan. So what I can do is I can take that statement and pull it directly out of my trace file, and I can then go and use Control-L or alternatively query display estimated execution plan. And when I display my estimated execution plan, what you'll see is that I've got a missing index here. It's doing a table scan. So one of the things that you also see is I've got this note up here. And that note is because SQL Server, every time it executes a query that it thinks it could have performed more optimally if there was an index there, it writes that to the missing index stats dynamic management view. And when we go and utilize Profiler, we can then go and see that. But what I want to do is I want to then be able to, so I'm walking through this process, I then want to be able to go and determine, okay, that was the estimated execution plan. What was the actual execution plan that SQL Server used at that particular point in time when it executed that query? So what I've got here is I've just got a CTE, so basic common table expression. What it does is it goes and brings in basically my exec SQL text, because inside of exec SQL text I then go and have my hash. That query hash contains the SQL statement, but it also goes and contains the execution plan that was then gone and utilised by that query. It also allows me to break down and see the total I/O, the total CPU that was utilised. So what you'll see here is I've got an execution plan. I can click on that execution plan, and this is the actual plan that SQL Server used in order to execute that query, noticing that it's different to the estimated execution plan. But what you'll still notice is that most of our performance impact is on our clustered index there. So what we can do is we can come back to our query here, back into my Analyze. And what I want to do is now see if there are any missing indexes, because what I'm doing is I'm looking at the DB missing index details. That will then show me that yes, there are a number of missing indexes that I have directly across my SQL instance. But look, I'm a pretty lazy DBA, so what I want to do is I want to be able to script that process. So I've just got a query here. It just joins in a number of different dynamic management views to then go and create those indexes for me. And what I can then do is I can also then filter those indexes based on the performance gains that I'd expect to receive as well. So once I've gone and scripted that index, what I then want to do is I then want to come back and I want to create that index. Once I've created that index, what I then want to do is go and have a look at my estimated execution plan. And now what you'll see is that rather than all of my performance being a clustered index scan, it's now being a table scan, it's actually now an index seek. So as a result, I've then been able to go and identify what the problem was and then resolve that. But remember we said we had two poor performing queries in there. We saw that one with the update where it was being blocked. So let's have a look at how we can then go and identify that blocking information. So what I'm going to do once again here, I'm simply just going to hit my table here. I'm going to use, this is the SQL perf table. So this is where I went and brung all that information directly in from perfmon, loaded it into a temporary table. Event class 137 is when I go and have a long-running block in there. So I can then go and straight away isolate, is there any long-running blocks in there? And as we'd expect, we do. If we expand that out, we can then go and see all the information directly about that block listed in here. If I come back inside a profile and I just do a quick find, search my, go and find next. Okay. So very similar to the way that we then go and have our deadlock graph. You'll see that we then capture all of that information just inside of an XML fragment there. So we can then go and see who the head of that blocking chain was. So what we've walked through there in that demo is how do we go about bringing all of those tools that we have inside of our arsenal together to go and diagnose a real-world SQL performance problem. What we've looked at is we've looked at how do we go about using perfmon to isolate and identify as it's SQL Server that's causing the problem. We've then brought in profiles to then capture that information, and then we've brought in a number of the dynamic management views as well to bring and isolate where those issues are occurring. So you can see that by walking through a methodical cookie cutter process, we can easily then come to the conclusion of being able to triage where the problem is and then be able to then go and once we've identified it, fix the problem. So what are the key takeaways from this session before we look to wrap up? Well, one of the key takeaways is knowing your baseline. Where is the performance problem? I don't want to be spending my time looking for a performance problem that's really a furphy. I really want to know what are the characteristics of my system? How does it behave? Is it really always slow on a Tuesday morning? Don't know, but let's get a baseline and find out. Because what it allows us to do is do the comparison and also allows us to capacity plan over time as well. Because we can then see over time that performance is potentially degrading. The other key takeaway is we really want to just from a performance tuning perspective is isolate things into bite-sized chunks. So very, very small granular ways that we then go and identify where the problem is. It's that whole concept of actually chewing them out in one bite at a time. So just breaking it down into small things. But the other thing is really understanding all of the different arrows that we have inside of our quiver as a DBA and when is the appropriate time that we then go and utilize that particular tool. Because you can see by combining all of those tools together, we actually get a better view rather than just focusing on one particular tool. So folks, that brings us to the end of the presentation this afternoon. We're going to open up the floor now for open Q&A for a couple of minutes, and then we're just going to take any Q&A you have outside just for the next presenter that's setting up. But folks, don't forget to go and fill in your evaluation forms, and once again, thanks for your time this afternoon. You want a copy of those? Sorry? You want a copy of the script? Yeah. Yeah, no worries at all.
What's the best way to do it?
Just give me your email address and I'll provide them to you. It's no worries at all.